possibly the most important shape that we use is the triangle. And really a triangle is just three sides connected at points called vertices. And this, of course, results in three angles, triangle. There's going to be these three classifications of a triangle. An equilateral triangle has the side measures always being the same. So there's three. This is the same as this, which is the same as this. So if this was 3 feet, this would be 3 feet, and this would be 3 feet. And as a result of that, all of these angles are going to be the same. An isosceles triangle has two sides equal. So if this was 5 feet here, this would be 5 feet here. And this side is not going to be the same thing. If it were the same thing, this would not be an isosceles triangle, but it would be an equilateral triangle. So this third side is always going to be a different measure than these two sides. Now, as a result of these two sides being equal, these angles are going to be equal to each other. Now, here we have three sides being equal, two sides being equal. Well, the last case we can have is one side being equal, but that's the same thing as saying no sides are equal. And that's what a scaling triangle is. All three sides are different measures, and therefore all three angles have different measures. In the normal geometry that we work with, this is called Euclidean geometry. The sum of all the angles in a triangle adds up to 180 degrees. So there are other geometries called hyperbolic and elliptic where this is not true, but for our purposes, we're always going to be working in this Euclidean geometry. And so we always expect this to be the case. The sum of the angles in the triangle adds up to 180 degrees. So if I were to ask the question, if these three angles add up to 180 degrees, and that means I could say this is x, x, and x. This is the same thing as saying x plus x plus x equals 180 degrees. And this is actually the same thing as just saying 3x equals 180 degrees. That means we actually can find this, right? Divided by 3. All equilateral triangles have 60-degree angles on all three of the angle measurements. It cannot be anything else besides that. This is the only way that it can work out for all three angles to be the same. Now, in general, we can solve problems like this by just looking at the unknowns. You can use whatever variable here. I've been using x, but let's use alpha here, the Greek letter A. And we're asking alpha plus 118 plus 27 equals 180. What value of alpha makes this equation true? Well, we know that 118 plus 27, these are just whole numbers that we can add. Doing that, I get 118 plus 27, 145. And I can subtract 145 to get alpha by itself. And that's going to give me 35. So if I have a 118-degree angle here, a 27-degree angle here, this one has to be 35 degrees. There's no other value, no other measure of that angle that it could be. All three angles are different. This is a scaling triangle. All three angles are different, therefore all three sides are going to be different. Now, what are all the angles in an isosceles triangle if one angle has measure 104 degrees? So the question here is, if one of these angles have the measure 104 degrees, what are the other two angles? Well, because an isosceles triangle always has two angles equal to each other, and that means that if one of these angles was 104, that means the other angle would have to be 104. So 104 degrees is something like this. Let's see. We have a 90-degree angle here. A 104-degree angle is like this. Well, it's a little bit less. This is a 90-degree angle. 104 is going to be somewhere around here. Let's say that this was one of the common angles there. That means that this is also going to be 104 degrees. So this was 90 degrees, 104 degrees there. And you can see that I cannot connect these two lines. If they just keep going straight, they'll never connect. That's because this is not a triangle. These two angles cannot be 104 degrees because we know that all three angles add up to 180 degrees. So if this was the same as this, and these are both 104, then this would be x 104. It'd be something like this: x plus 104 plus 104 equals 180 degrees. That's the same thing as saying x plus 208 equals 180 degrees. And you can already see what number plus 208 is 180. X has to be a negative number to do this, and that doesn't make sense. We can't have a negative angle for this application. So we know that the 104 degree angle, this has to be the third angle that's not known. And 104 is an obtuse angle, so the isosceles triangle is not going to look like this. It's actually going to look more like this. Let's do it like this. Let's get 90 degrees here. 104 is like this, in some fashion like that. And then isosceles triangle here would be just connecting these two dots like this, these two lines. These are going to be my equal sides, and these are my equal angles. This is going to be 104 degrees. And these two angles, which are going to be the same, I'll label as beta. So to find these measures, all we have to do is use the fact that the triangle's angles add to 180 degrees. We know that we have 104 plus, and there's going to be two of these, 104 plus beta equals 180 degrees. Well, this is the same thing as, right, plus beta. This is repeated addition. This is the same thing as multiplication. And we are multiplying them 2 times. So this is the same thing as 2 beta. So to solve this, this is a 2-step equation. I'm going to subtract the other term. This is going to give me 76. And then I'm going to divide by 2 to get beta by itself. So the angles must be 38 degrees. So 38 degrees, and 104 degrees. Those are all the measures of that isosceles triangle. Now, a special type of triangle is called the right triangle, right? This is where one of the angles is a right angle or a 90-degree angle. Which one of the 3 classifications can the triangle belong? Well, we already know that an equilateral triangle has all 3 angles equal, and we know that those all 3 have to be 60 degrees. So a right triangle cannot be equilateral. However, I can create a right triangle like this, where these 2 sides are equal, therefore these 2 angles would be equal. And we can actually calculate those 2 angles, because if this is 90 degrees, 90 plus what equals 180? Well, that means that x equals 90 degrees. These 2 have to be the same angle, and they have to add up to 90 degrees. Therefore, they both have to be, so if this was y and y would have to be 45. So a 45 degree, 90 degree triangle is an isosceles triangle and a right triangle. You can, of course, have a scaling triangle. I can do that very easily. This one right here is a scaling triangle. You can also draw it like, draw it taller and then thinner down there. This is always going to be scaling because this side is going to be greater than both of these, and then this side is clearly smaller than this side. So scaling triangles, scaling right triangles are very common. Now, right triangles are very nice because the Pythagorean theorem applies to them. And that's always going to be a squared plus b squared equals c squared. And this is how it's labeled. A and b are they're both the name of the of these sides, but also the measure. A equals a certain length. A and b are called the legs of the right triangle because they're right next to the 90-degree angle. So it doesn't matter which one's labeled A and which one's labeled B. They can be flipped around and this will still apply. What is important is that what's opposite the right angle is the C side, and this is called the hypotenuse. It's always opposite the right angle. As long as you find the hypotenuse correctly, then A and B can be whatever, and it'll always work out. Okay, so we can use, as long as we have a right triangle, we can use Pythagorean theorem. And it says here, we need to find the missing side lengths here. Well, if we have this triangle like this, then these are the two legs because they're right next to the 90-degree angle. And this is the side opposite the 90 degrees. So this is the hypotenuse C. So I can label this one A and this one B, or I can flip A and B around. It will still give me the same answer. So A is 12, so 12 squared plus B is 7 squared equals C squared. We have 144 plus 49, which gives us 193. And we're asking the question, what squared is 193? This is the same thing as asking, what is the principal root of 193? We're always going to look at the principal root because it's going to be positive, which we have to have here. This is a distance, and a distance is always positive. So we can take the square root of 193, and that's going to be 13 point, I'm going to approximate it to two places. 13.89 is the measure for C there. Okay, this one, again, we have a right triangle, which means we can use Pythagorean theorem. This is a leg, and this is a leg. This is labeled A, so I'm going to label this one B. And this is the hypotenuse. It's always opposite the right angle. So this is going to be C. So now we have A squared plus B squared equals C squared. 3.8 squared is going to be 14.44. And 17.3 squared is 299.29. Okay, we need to get the A squared term by itself. This one, in this case, C squared was already by itself, so we didn't have to move anything around. For this case, we have to get the A squared term by itself, and then we can do this square root process. I'm going to subtract the 14.44. I get A squared equals 284.85. And here we're saying what squared equals 284.85. That's the same thing as saying A equals the square root, the principal square root. So it's going to be positive here. And doing that on a calculator, I'm going to approximate it to two places. So approximately 16.88. That's what gives us this is going to be a scaling right triangle, just like this one was as well. Okay, this one, you can see that this is the right angle because it looks that box like that. And we can see that these two are then the legs. So this is going to be A, this is going to be B, and this would be C, but it's labeled X, so let's just label it like that. This is the hypotenuse. So we know that 10 squared, which is A, plus 12 squared, which is B, A squared plus B squared equals C squared, the hypotenuse squared, which is X. It's going to be 100 plus 144, or 244. So what squared gives us 244? That means that we just need to do the square root of 244. And I'm getting, once again, approximately 15.62 for that problem. Okay, for this one, we have, once again, a right triangle because this is a box angle, a square angle. And 15 is the hypotenuse. So Y is a leg, and then here we can call this one A, for instance, or B. It doesn't really matter. So we have a squared plus b squared, which is going to be y in this case, equals the hypotenuse squared, 15 squared. So 144 plus y squared equals 225. Once again, we need to get the y squared term by itself. I'm going to do that by subtracting off the 144. So I get y squared equals 225 minus 144 is 81. So what squared equals 81? What's the principal root of that? Y must equal 9. 9 squared equals 81. Now, what is the hypotenuse if the legs measure 3 units and 4 units? So we have 3 units and 4 units. What does c equal here? We have 3 squared plus 4 squared equals c squared. That's going to be 9 plus 16 equals c squared, or 25 equals c squared. So in this case, right, what squared equals 25? C must equal 5. If they measure 5 and 12, well, 5 is going to be like this. 12 is going to be a lot longer. 5, 12, and C. So we're going to have 5 squared plus 12 squared equals C squared. 25 plus 144, or 169 equals C squared. And if you put that in a calculator, you're going to find that C here equals 13. And this problem and these two ones all show Pythagorean triples. Pythagorean triples are just 3 whole numbers that satisfy the Pythagorean theorem. In this first case, the Pythagorean triple was 9, 12, and 15. 9 squared plus 12 squared equaled 15 squared. For this one, we had 3, 4, 5. 3 squared plus 4 squared equaled 5 squared. And finally, for this one, we had 5, 12, and 13. 5 squared plus 12 squared equals 13 squared. These are Pythagorean triple. There are infinitely many of them. Really, this one and this one are actually the same thing. I just multiply all of these by 3. 3 times 3 is 9. 4 times 3 is 12. And 5 times 3 is 15. So these are actually the same Pythagorean triple, but you can scale it up or scale it down as much as you want. Okay, we have a couple application type problems. 2 trains leave the same station at the same time, and one traveled south and one traveled west. So if this is the station, so one traveled south and one traveled west. When the southbound train had gone 75 miles, so this was 75 miles, the westbound train went 125 miles, so 125, something like that. How far apart were the 2 trains at this time? And the distance between the 2 trains is the straight line distance, is this distance here. So we're asking, what is this distance? Well, this is a right triangle because we're going south and west. Those are exactly perpendicular, as it's called, is the 90-degree angle there. So, and we have 2 legs of the triangle, so we can find this one, which is the hypotenuse, right? It's always opposite the 90-degree angle. So I'll label this with X. So we're going to have 75 squared plus 125 squared equals X squared. I'll use a calculator for this. 75 squared plus 125 squared is 21,250. So what square equals 21,250? That's going to be the square root. So that's going to give us, it's going to be approximate 145.77, and these are all in miles, so it's going to be miles here for our solution. So they're approximately 146 miles apart at that particular time. Now, screen size is always measured by the diagonal because the diagonal is the largest size that you can have for a rectangular screen. So if a TV cabinet that where a TV would fit into, right, is 40 inches long and 34 inches tall. So it is 40 inches long and 34 inches tall. So this is where a TV is going to sit inside of it. This is 40 inches and 34 inches. How large a screen can fit in here if we include a 2-inch spacing on all sides for the TV's edge. So there's going to be 2 inches all the way around so that we have the edge spacing for the TV. So the TV can fit right into the inside of here. And this is the diagonal where we're asking about. This equals what? So all we're going to need to do is figure out, because this is going to be a right triangle here, all we have to do is figure out what is this side length and this side length. These are going to be the legs of the triangle. Well, we know that this is going to be the height of the TV cabinet, which is 34 inches, but we're going to remove off 2 inches from top and bottom for the edge of the TV. So we're only really measuring the actual screen size, not the full, with the edge of the screen. So it's going to be 2 inches less here and 2 inches less here. 34 minus 2 is going to be 30. And the same process here, the bottom leg of this triangle is going to be 40 inches, but we're going to move off 2 here and 2 here. So it's going to be 40 minus 2 is going to be 36 inches. So what size TV can we fit in there? It's going to be 30 by 36. So we're going to do a squared plus b squared equals the hypotenuse squared, right? X is going to be the hypotenuse. And doing 30 squared plus 36 squared, I get 2196. So what squared equals that? It's going to be the square root of 2196. And I'm getting approximately a 46.86 inch screen will be able to fit in this TV cabinet.